All right, hey AP Chemistry. So I wanted to finish the rest of your notes from pages 11 and 12 using a video. So make sure if you want to get the rest of your notes, you are paying attention and copying from this video. So the last thing that I wanted to talk about was the structure of metals and alloys. So for metallic bonding, there's a very specific way in which the metals bond with each other. These electrons are weakly bound, as you can see by the description of this diagram. Typically, you represent metallic bonding as having electrons as a sea of electrons. So metallic bonding is represented as a sea of electrons between metals. So that's why it has to have its own specific name, because it's not really covalent and it's not really ionic. The electrons are kind of hanging around all of the positively charged metals, or they are more slightly positive because the electrons are moving around. And so as you can see, this kind of looks like this shady area. That's the electrons moving around. And that is why metals conduct electricity. Why metals are able to conduct electricity. Metals conduct electricity as a solid because the electrons are able to move around, and to conduct electricity, you need the movement of electrons. Now, metallic bonding can take on several different forms. So the first type of form is an alloy. An alloy is a metallic material that contains more than one element. So alloys have metallic properties, but they can consist of either two or more metals, or a metal and a nonmetal. We broadly classify alloys as substitutional and interstitial. These are going to be big terms that we're going to talk about. So an alloy is a metallic material. So an example of an alloy is steel. Steel is not a pure metal. So like an alloy is technically a mixture. It is not a pure substance. So keep that in mind. It's a solid mixture, uniform throughout, like steel. If you've ever seen or experienced steel, it looks and feels like metal, but it's multiple metals or multiple elements in there. Typically two metals, but it could be a metal and a non-metal, and we'll talk about that. So that's what an alloy is. Now, a substitutional alloy, one definition you're going to have to recognize, is when one metal atom substitutes, hence substitutional, for another in the crystal structure. We mentioned crystal structure is like the positive and negative ions kind of all connected in a solid structure. So when I'm talking about crystal structure, you get like positive, negative, positive, negative, positive, negative, positive, negative, positive. This is like crystal structure. This is also crystal structure. All of the atoms are in a specific array. So a substitutional alloy is when one metal atom substitutes for another in the crystal structure. The crystal structure may either stay the same upon the substitution, or it may change to accommodate the differences between the atoms. So what that means is the properties may be the same, or properties can be strengthened or weakened, right? So the crystal structure may either be the same or change. For two metals to form a substitutional alloy, and this is what you have to know for the AP exam, the radii of the two metal atoms must be similar. So I can't have a large and small atom together. It says usually within 50%. You don't have to memorize that. Just know that it has to have similar size. And so an example is nickel and copper alloy. As you can see, you probably can't see it in here, but if I were to draw kind of like a different color, this is probably the copper in a nickel alloy. So I'm just shading, and it looks kind of dark. I shaded a couple of different ones. They are about the same size. About the same size. It's two metals, and it's mixed. Alloy. Okay? So that's a substitutional alloy. So again, an alloy are two metals mixed. Substitutional alloy is I have one metal that replaces, substitutes another metal in an alloy in that mixture, and it's about the same size. Okay? Another type of alloy is an interstitial alloy. So in an interstitial alloy, small, usually non-metallic atoms fit in between the metallic atoms of the crystal. Right? The alloy maintains its metallic properties with these interstitial atoms in the structure. Interstitial alloys contain atoms of one kind that fit into the holes, or interstitial sites. That's why it's called interstitial. It's a hole of the crystal structure of the other metal. In metals with the interstitial elements hydrogen, boron, nitrogen, or carbon, the alloy that results retains its metallic properties. Usually we'll see carbon, and I don't know if you can see in this picture, this would be an alloy. I have iron, and I have these smaller atoms of carbon in here. And it kind of pointed it out. This is interstitial because they are different sizes. Different sizes. Fits in small holes of metal structure. So the only reason why it's an alloy is because there's two different elements that make a metallic type of structure. A summary, and I have these all looking the same color, but we could do that. A pure metal would have all of the particles all the same color. All the same color. A substitutional alloy, and you can kind of see that they're a little bit two different sizes, but I'll shade them. A substitutional alloy is an alloy in which you have two atoms, typically metals, that are about the same size mixed throughout. So two metals about the same size mixed throughout. Then we have interstitial, which is in this bottom left. Look at the interstitial. You could clearly see that I have small atoms that fit in between the holes of this metal. So without these holes, interstitial atoms, interstitial holes, and an atom fits within the metallic structure. This is known as an interstitial alloy. Again, alloy is two metals, or a metal and a nonmetal, and they make this solid mixture that's metallic. Okay, and our substitutional alloy has that mixture of two metals, and they're about the same size. An interstitial alloy is a mixture of two metals, or maybe it's typically a metal and a nonmetal. Typically, metal and a small nonmetal that fits in between the hole. And then here's like a mixture of the two, substitutional and interstitial. I have like the holes here, and then I have atoms that would probably be like a little different color. All right, so I'm shading in where interstitial and substitutional has occurred. Okay, like this one. Okay, all that shading in is other atoms that are different than the element. Now, if you wanted to gain a little practice, there is a big question on the last page of our notes, which is question 42. It comes from the AP Chemistry 2014 exam. This would be a type of question related to substitutional and interstitial alloy. So type of question for metallic bonding. So all I want you to know from these notes is the type of metallic bonding. We have an alloy that is a typical metallic bonding, and there's substitutional or interstitial alloys. Know the difference between the two. And then also know that in metallic bonding, the electrons are not really held tightly between the metals in the metallic bonding, so they kind of flow around and move around, and that is exactly why metals conduct electricity as a solid. All right, so this is your video notes for pages 11 and 12. I am not going to go over these notes in class, but these answered notes will be available on the Google Classroom for all of you.